Part 2, reflection and refraction. Here we've got the table of indices of refraction, and speed of light will be smallest in. So whichever one has the highest index of refraction, that's going to have the lowest speed. So light's going to go slowest in this, next slowest in that, faster, faster, faster in a vacuum. Where would the actual fish be in the diagram on the right? So when I think about light passing into and out of denser materials or materials with higher indexes or indices of refraction, I think of the car thing. And it doesn't matter whether you imagine this guy shooting laser beams out of his eyes and those laser beams going into the water, or if you imagine light coming off the fish and going into the guy's eyes, it works the same either way. So if you think of a car going into the water, here are the wheels. And it's going like this. When it gets to the water, this front right tire right there is going to hit the water first. And that's going to slow it down. So this is moving fast still because it's in the air. This is moving slow, and that's going to make the car turn this way. Now it's not going to do a U-turn. That's crazy. So it's going to be fish B. Now if you reverse this and you imagine a little car coming out of the water, as it comes out, the first wheel to come out is that front right wheel. So it's going to be in the air where it can travel fast. This wheel is still in the water where it's going to be traveling slowly. So this goes fast, this goes slow, and that makes it turn to the left also. So it doesn't matter which way you look at it. Light coming off the fish going into the person's eyes, or somehow the guy's eyes shooting laser beams at the fish. In reality, if the guy's looking at the fish, that means light is coming off the fish going to the person's eye. At any rate, this is where the fish is, but the guy assumes that light travels in a straight path, so he thinks the fish is over here. This is where the fish appears to be. So fish B, that's the one that would be the actual fish. Total internal reflection, it happens, let's say we've got some water here, and if you do have a flashlight and you're trying to shine it out of the water like this, it might make it out of the water. But if you shine it at a really low angle like this, I don't know, there's some angle, the critical angle, and if it's a low enough angle, none of that light's going to get out. It's all going to be reflected. And this happens in this case because water has a higher index of refraction than air. It's not going to happen up here. You don't get total internal reflection if you have the beam in the air shining toward the water. It's only from a higher index of refraction to lower. So this question about in which situation can total internal reflection not occur, it can't occur here because we're going from a lower index of refraction, 1.000293, to higher, 1.52. All these other ones are going from a higher index of refraction to a lower, higher to lower, higher to lower. Number 5, speed of light is 1.5 times 10 to the 8th meters per second. What's the index of refraction? So we have this formula for velocity equals the velocity of light through some medium is the speed of light divided by the index of refraction. If you rearrange it, the index of refraction equals speed of light over velocity. So if that's the velocity through this material, plug it in here, plug in the speed of light, divide 3 by 1.5, and you get 2. So that 2 is the index of refraction. Number 10, need to make this, well, I don't know. Maybe I could get away with this being really small and just zooming in and being careful. I'm going to do my car thing. You can do, oh, I lost it. You can do calculations to figure this out, but I like to think of the car thing. So I've written the 3 indices of refraction. Highest for diamond, lower for glass, lower for air. And I'm going to imagine a car driving along this way, going into the glass. So since glass has a lower index of refraction than diamond does, that means this part of the car, this right front tire that goes into the glass first, that's going to go faster. The part that's stuck back here in the diamond is going to go slower, and that's going to make it turn to the left. And then the car is going to go this way, and as it reaches this interface right here, this part is going to go into the air first. This part's going to be stuck in the glass. Glass has a higher index of refraction, so this is going to move slower, this is going to move faster, it's going to make it go to the left again. So the answer is A. Oops.